In this video, we will look at how to connect an external GPS antenna to the V6 and how this improves the time base. In an earlier video, we discussed the PPM connector and the 10 MHz reference clock for external signals. Here, the focus is on the GPS connector. This is the GPS connector where a GPS antenna is attached, preferably an active antenna. The V6 provides 3.3 volts to power the GPS receiver. Next, we will configure the V6 to use GPS as the clock source. Start a new mission by going to File and selecting New Mission. When prompted, choose No to discard any changes to the current mission. Slide down the Blocks panel on the left to clear the workspace. In the Analyzer list on the left, double-click the Spectran V6 Eco block to open its device panel. At the top of this panel, click the gear icon next to the Spectran V6 Eco tab title to open the configuration menu. Expand the Board Config section. Under Stream Clock Source, select GPS from the drop-down. Under GPS mode, select Location and Time. Turn on the V6 by clicking the circular power button below the Spectran V6 Eco label in the Analyzer pane. The Device Information panel on the right shows the device status, including the serial number and GPS fields. Initially, the PLL is locked to the internal TCXO, and the GPS SVs field shows the number of satellites being tracked. Synchronization to GPS time can take a little while, as additional satellites are acquired. Once enough satellites are tracked, for example 11 SVs, a valid GPS time appears in the GPS time field. The GNSS status indicator at the bottom of the device panel turns yellow to show that GPS time is being used for synchronization. In standalone mode with only the internal TCXO, the time base accuracy is about 0.5 parts per million. With the optional OCXO module, option 112/002, the PLL frequency stability improves to around 5 parts per billion. With the GPS discipline time base, GPS-DO, option 122/044, a high-stability local oscillator, TCXO or OCXO, is disciplined by GPS time. In this configuration, the GNSS TCXO accuracy reaches roughly 5 parts per billion, and the GNSS OCXO accuracy can be on the order of 200 parts per trillion. This provides a highly stable GNSS time reference, but is used for time, not position. As a byproduct, a 1 PPS pulse per second signal is output on the PPM connector. This 1 PPS signal can be used to daisy chain and time synchronize additional instruments. Looking at the signal flow, the GPS signal from the active antenna is applied through the GPS connector. The PPM signal path feeds the PLL, which refines the accuracy based on the selected TCXO or OCXO configuration. At the same time, the PPM signal is sent to the synchronization logic. From there, the 1 PPS signal is provided on the PPM connector to support time synchronization of other devices. Keep in mind that this is time synchronization, not phase synchronization between instruments. To recap, open the V6 device panel, go to the Configuration menu, expand Board Config, set Stream Clock Source to GPS, and set GPS mode to Location and Time. With an active GPS antenna connected, the V6 then locks its time base to the GNSS signal and outputs a 1 PPS timing reference. For more information, check out our other videos on our YouTube page or visit erroniausa.com.